Here is part 2 of lesson 7.7 for Algebra 1. We're going to focus on exponential decay. Exponential decay is a specific type of exponential function modeled by y equals a times b to the x, where a has to be greater than 0, and the only difference is now that our b has to be between 0 and 1. So something like 80% or a half or something like that. So we're going to get smaller. So our exponential decay factor is going to make our amount decrease. So if they give you an r value, you have to make sure you do 1 minus the r value to plug it in. So that number has to always be something that's less than 1. So if we take a look at what the graph should look like, we start at a high value, so this is our high value, and it decreases and it gets really, really close to 0. So again, sometimes people call it a hockey stick, but this is exponential decay. So same process as before, physics. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. What is the approximate pressure at an altitude of 3,000 meters? So in the word problem, it says our pressure decreases at about 11.5%. So that's telling us that this is an exponential growth model. Decay. So we are going to use the formula y equals a times b to the x. So if we look at our initial sea level, we're at 101, and our pressure is going to be 1 minus that rate. And we are doing that for 3,000 meters. But you have to remember it says for every 1,000 meter increase. So that means we have to figure out how many times did we increase 1,000 meters. So we're thinking 3,000 divided by 1,000. So how many times is that? 3. So this is what our model would look like. We get 0.885 to the power of 3. So if I work this out on my calculators, I get 70 kilopascals. Go on and read the next question. Please pause the video while the students work. So in this problem, our initial population is 97,000 people. We are given a rate, and it decreases at 3%. So we lose 3% every year, but we keep 97% of the population. So you have to make sure you do your 1 minus r before you plug it in. So when we calculate, we get 67,302.7 people. If you want to round up to the nearest person, that would be okay. Let's try the lesson check. What is the growth factor in this equation? Which number? Yep, you got it, 4. So it would be quadrupling every time. Number 2, what is the initial amount in this function? The 15, and it would be tripling each time. What is the decay factor in the function? So notice it says factor and not rate. So factor means what number is in the equation, so that's going to be 0.2. Otherwise, we'd have to say, oh, 1 minus r is equal to that. So then we would say that the r value is 0.8 or 80%. But in this case, it says factor and not decay rate. Number 4, a population of fish in a lake decreases 6% annually. What is the decay factor? So what number do we plug into the equation? Is it 6 or 1 minus 6? 1 minus 0.06. So we lose 6%, but we keep 94% of our population. So in the equation, it would be 0.94. Number 5, suppose your friend's parents invest $20,000 in an account paying 5% interest compounded annually. What will the balance be after 10 years? We like it when it says annually because our problem is a lot easier. So $20,000, 1 plus 0.05, so 1.05, and we're compounding for 10 years. So I'll just tell you the answer to that, $32,577.89. So we made about $12,000 bucks. Number 6, how can you tell if an exponential function is growth or decay? So growth, what does our scale factor have to be? Greater than 1. Decay, our rate has to be less than 1 and greater than 0. This concludes the videos. Watch the videos again at home if you think you need more help.